Okay, so against my saner planning of doing some networking, that's not going to happen. Few comments. Some of you pointed out that that the review form of the assignment 2 is, you're right, not quite correct. There is a species endpoint in there, which may dangerously remind you of assignment 1. If not, you probably didn't do assignment 1. I renamed it now generously into other endpoints. The problem is I can't change the layout anymore once people have started submitting because of the fixed schema, right? I mean, I would break the schema of the review form for everyone who did it already, which is not fair. So I renamed it to other endpoints. This would then include the discussion of, other endpoints, I guess, right? In particular, that includes the webhook elements and the if people did another endpoint on top of it. Again, recall there was only the commitment to actually do 2 endpoints, right? So plus the status one, which probably most commonly is the commits and the languages one. But if you did the issues one, that would need to be captured here. It's kind of a bit shitty right now. Sorry for that. I don't like this at all because we need to disambiguate it. But that's how it is right now. So I don't see any other way of doing this without especially breaking older reviews, because many of you have done reviews already, so you should be fine then. Just bear in mind, just use it for anything else, webhooks and issues if used. Yeah. So that's on that one. The other thing I wanted to, so that's assignment related. Thanks for pointing this out. It's very helpful. The other thing that Jone talked about yesterday briefly, that I just want to pick up on conceptually, is the idea of Docker multi-stage builds and what this all is about. Did you guys get, how far did the discussion go on multi-stage builds in Docker yesterday? Not too far, right? Good, okay. So one of the thing is, one of the purposes of Docker, and I mentioned it just in the best practices, was that images should be reasonably small, right? We want to minimize the image size. It's one of the premises when you use Docker. We only want to have elementary services, elementary libraries that you need binaries that are associated with it. Sometimes the libraries that you actually put in Docker container themselves can be quite large. And one classical example for this one is actually Go itself, for example. So Go actually consumes a few hundred megabytes if you install it comprehensively in an image or generate an image from it. But basically the application that you would write, hang on, I'm just using the what would happen in practice is something is that you have your Golang environment, you deploy, you copy your execute, or you copy your source code in, you compile your source code and run it, right? So the thing is there, every time you do this one, if you have this kind of Docker file that starts with a from Golang, which is fine, you can do this. So this is just an environment that has Golang, in this case 1.73 installed, in our case something else, right, 1.13 and so on. The only challenge is there, you're always bringing along this entire build environment in your deployed application. That's the pain there, right? So because Golang contains, of course, Go build and all the functionality around in this, plus additional packages and that you actually don't really use, that are pre-packaged with Go. But in many cases, you just want to have the actual executable in your Docker file, right? Because you're not modifying this ever. You're only running this for one purpose, to run the application, right? And as part of it, building it. And in practice, it means it becomes a bit painful. So you can either, of course, use Golang completely and basically build everything inside that Docker container and then fundamentally run the executable. The second pathway, what else can you do? What would be an alternative of doing this? It's your intuition. So I have my Go application. So I'm suggesting pathway, hey, easy, let's use a from Golang image, do a build in there, and do finally the run in there. Again, what's the pain here? Is there pain in here? Well, my point is, this Golang image, 113 or so on, is pretty heavy, right? So it's 100-ish megabytes on its own. Your application, what's the size usually of your applications? Has anyone looked of their compiled application, what the size is? Any guesses? Exactly, in run that league, right? So below 10 megabytes in any case, but somewhere in that range, so nothing, right? And the thing is, you're bringing along a lot of baggage just for running, if you want to do that, just for running your actual executable at the end, right? So what could we do to make this a bit easier? Or what conceptually could be done to make this image smaller? Because again, the rule was about small images.
It's possible like install Go on your own and then just install the parts that you want to do.
Okay, that's an interesting one. So you want to cherry pick from Go. So you basically copy. Oh, that's interesting. So you suggest that's the first. Okay. So you have a base image, so it's empty. There's actually one image quite funny. It's called Scratch, so it's like from Scratch. So that's like there's nothing in there, and you can copy anything in there. That would be your angle. And saying, okay, I'm literally copying the parts of. I'm not even sure how to write this. Parts of Go. Is that a good practice? Probably. I mean, we'll make a small image. I'm with you on this one.
Lot more work.
Lot more work, right? What else? Is it maintainable? Yeah, most likely, right? So if you upgrade a version of Go, you not only need to try the latest version of Go on it, you probably also need to figure out the subset of packages that you have actually used, right? So, yeah, interesting. So let's see, what other pathways could we think about?
You only need Go to build the executable. So once you have the executable, you just need the executable.
Cool. So how can we do this?
You can copy it from the first image into a new image with
There
another
you
from
go.
statement.
Beautiful, right? So, exactly. So, the older way, before that feature was introduced in Docker, was to basically do this by hand. So usually you have some sort of bash script that does, it assumes again, oh, please have your Go library, your Go environment installed and so on. Run the following command, right? Like run Go build, and the executable. Please copy this in this particular location and then run your Docker file, because then the Docker file would say, oh, add this file from your repository into the actual build image, right? The image would be very small. But it's again painful because it breaks all the ideas that Docker has automating things, because you still had some bash script, some manual configuration, copying around files, a nightmare. So I forgot 117, someone will know, I'm sure, in the room. They introduced in Docker the idea of multi-stage builds. There's the idea, exactly as Carl has mentioned just before, is that you can chain multiple images. So you can have one image that actually works based on the classical Golang base with 300 megs of libraries, environment, and so on, that sits inside your repository. And the only purpose it does is actually to build your Go code in a minimal way using some parameters to optimize and so on. And afterwards, a second image is created, which copies the output from the first image into the second one. And then the second image is the only one that is actually deployed. So, and that's the idea here. Again, this side is linked, but it explains the essence more concretely. So in the past, it has been often like this, that you have a shell script that allows you to build some. So basically, you run Docker build manually and then copy it somehow magically into the Docker file. So that would have been a Docker file. This would have been the shell script for building. Yeah, that's a good point. That's a very good point. So much about my empathy. It screws it up a bit. Hang on, I didn't want to have that. There you go. So the idea was there basically that the Docker file is incredibly simple in those primitive examples. It basically just means prepare some environment and then copy something into the root directory of that Docker image and run it. Run the command F, that would be the executable. But the heavy lifting would be done down here using a conventional bash script, which basically works on your development environment or preparation environment. And and does a lot of kind of stuff and copies stuff around. And it's a bit of a nightmare there. So the idea was, hey, can't we do that easier? And here, that's where the idea of those multi-stage builds comes in. And what Docker files, and that is only one Docker file here, what Docker files look like is like this. So instead of having one from directive, that's the key point, that signifies a new Docker image to be created, you have two. And the idea is basically there that you have the base image, you have the working directory, you download what you need, you compile your application. So this is basically the full script for compiling Go applications manually without optimizations with target operating system Linux, if you want to be very specific. And basically taking anything that sits in the particular directory, because it had been copied, app.go had been copied into the root directory of the image, is then basically run. So this does the compilation bit. The second one here says, hey, create a new image. And what does it do? Well, it says from base image, that's Alpine Linux, doesn't really matter what it is right now. It adds some certificates in order to allow HTTPS connections, for example. Doesn't matter right now. This is specific to that particular application that they're describing. You specify a work directory, and here's the interesting bit. That says copy -- from 0, and that says copy from the first image the following. And literally this path, so it goes into the first image, identifies this path, and copies it into the current directory. Now the work directory is root here. And then run it simply afterwards, right? So now basically you have two images in one file. One of them building, the other one executing. That's the only idea there that they can do. So it kind of recovers the idea of having having a full automation as a Docker file, as opposed to having this multiple this kind of patchworky approach where you still need to instruct the user to run bash scripts and configure the environment. You can also name those different instances. That's probably a bit more intuitive. So in this case here, they have aliases introduced from Golang 1.7 so on as builder image, do your building stuff, and then you create a second image. Instead of saying from 0, as we just saw before earlier, it says, well, copy from builder with reference to that image in this particular path to your current directory, basically, and then run it. So that's the key idea here. I want you to understand of how you can optimize your Go code in particular. This has nothing to do with multiple service composition or whatever else. It's just about optimizing individual Docker containers based on the available, based on the environment you have. Of course, for different programming languages, maybe slightly different, but this is literally the next to straightforward optimization that you could do for Go, so to have minimal images. If you run this just for exercise, I mean, if you're interested in exploring this, and do it the conventional way, just having a Golang image in which you compile and run, and just look at the size, and then look at the final image that's actually coming out of it, you'll be surprised how vast the difference is. Please.
If you make many images, what's like the fallback, like having too many images on one file? What's like
the max? Yeah. I don't know of any max there, because the idea is you can just change them, right? I don't know. Perhaps there's a theoretical maximum. I would need to look it. I wouldn't know.
Is it bad to have too many, or?
The question is, does it justify your use case in the end, right? So, I mean, why would you need so many? Right now, if we intuitively think about it, in many cases, for us, it would be sufficient to have a build environment and a runtime environment, right? So, if you see value in any intermediary stages, if you can justify them, sure. I just struggle to. I have not seen any case yet that has justified it. But it could be an interesting exercise to think about it in terms of decomposition. I'm not saying that's a very good point you're making. I just haven't seen it being used at all. But most important for you is just to know that this functionality is available. So even if you feel like, hey, I need to do some pre-processing or something, or we're using a bash script or the like, always check, can I do that somehow in Docker? Right? Perhaps you can. Can you do it in a different image? Does it need to be in the same image, right? Are you concerned about size? It's just more being out there and thinking about what are the ways and how we could improve what we have already for execution. So if you, for your assignments, only use the basic Docker image that has the full Go included, that's perfectly fine, right? This is kind of a more optimization route here already to look at, but I think it's very good for you to be aware of it, because in the future, when you look at Docker files, you will see more and more of this. Right? You see Docker files that actually more look like this, and you're wondering, hey, why is there 2 Docker files in one? Well, most likely it's that one of them is the build environment, one of them is the execution environment associated with this. So generally, I think, I'm not sure if you have looked at it, you probably didn't have the time, but I would recommend you to browse a bit through, especially through this area, develop images here. On the Docker documentation, is actually really straightforward, very, very readable, and has a lot of good tips and best practices along that line. So if you find the time, it probably wouldn't hurt to just go through some of those and see what's interesting. I cherry-picked 2 of them, which is basically best practices, which I think is really important to know, and the multi-stage builds. But there's also, of course, the Docker file reference, which is exhaustive with respect to everything that you can do in Docker. So, but it's quite lengthy, but it explains in very detail of how things are done one by one and how the idea of those different layers work. So after every command, a new layer is added to your image, those slices, and it also explains why you need to change commands, for example, and aspects like this. So it's I think very readable. Can be a bit long, but if you find something that's particularly of interest, use Control F and see if you find this represented. Also, if you forgot what expose stands for, what from stands for, what maintainer stands for, and whatever else, that's the kind of stuff you all find here in the specification. So it's all under docs.docker.com, and then the engine reference in particular. Very readable for a documentation. Mind you want to be clear about the version of Docker you're running here. One comment on Docker builds: you need to have version 1.17. Has anyone installed Docker already on their local machines or virtual machines? Yes? How did you do it?
DNF install Docker.
I see. Okay, right. Yeah, you're kind of ahead of the game. Yes. One of the points. One of the points that I want to make is in terms of Docker installation. I will post that again in the wiki. Don't use apt-get to install Docker. And the reason for this one is that you will generally get an outdated version of Docker, right? So you have that experience, have made this experience already?
No. But I was thinking that they usually have a site called get.docker, I think.
Sorry, again?
He's
yes.
saying that there's an install script on get.docker.com
That's correct.
that you can curl and pipe into bash.
That's what I want to get at. Okay, exactly. So get Docker. I just need to look at this, figure out the page again. It's literally a script that you.
I think it's get.docker.
Get Docker. Thank you. And then.
Docker.com.
Also.
It doesn't work on 1910. Ubuntu.
So get Docker in one.
No, get.docker.com.
Get.docker.com?
Yes.
Ah, voila! There you go. Cool. And actually, a link from it from the page. But this is basically a script that you run in your on your local machine. What it does basically, it sideloads Docker. It downloads everything. So that's ideally last time you need to run a bash script, because after that you can Dockerize everything. But this basically installs Docker. I'll post some instruction on this in the issue tracker, so you know how to install it properly. If you use apt-get, it is not deadly. The only thing that will not work is the multi-stage builds, most likely, because they are more recently introduced. I forgot. I think even 1.17, if I got it right. So you may be fine. It's written in the specification for the multi-stage builds. Let's see. Yeah, 17.05 or higher. So that's 17.05 or higher. So in Ubuntu, I think the LTS is slightly behind. I'm not sure.
If you try to install Docker through this on 1910 Ubuntu, you will have problems with there not being a release file for that the version. so you won't be able to use it virtually.
So if you
If you use the install script,
Yeah.
it will try to put in a release file that is for Eon Ermine, which doesn't exist, which is going to create problems by when you try to get packages, and it won't work in general.
okay, so you're suggesting they get it right, Docker 19 doesn't work?
So don't use Docker 19.10.
I
Use the
see.
long-term release.
That's just right. Okay. Yeah. Use the current or long-term release of Docker. Don't go to the development side. Okay. I post some instructions on how to do that, so you can instead set it up easily on your in your virtual machine. So it should be relatively straightforward. That's literally only running the script once, and you'll be fine. Then you have a Docker environment that does the job. Execution Docker generally writes sudo unless you make Docker member of the sudo group, which is something that's going to be on. Just bear in mind, if you get permissions denied, run sudo Docker to get somewhere. Okay, that has officially broken my intent for this lecture, which was to get to networking, which I didn't. But in any case, we got a bit more perhaps in depth on Docker, on some aspects of it that you want to look at it. Some of them, it's really more on the conceptual side, so you know what to look for if you need it. Doesn't necessarily mean we do it, right? So, because some of them topics were a bit more going beyond what we need. What I expect, though, is that you guys all write some Docker files and use them for deployment, right? For whatever the complexity. Think about best practices, would be good. That's it.